In today's video, we are going to talk about stellar evolution, how a star proceeds from a planetary nebula to a black hole. This is going to be interesting, so keep watching. It all essentially starts with what we know as a planetary nebula, huge chunks of gases which are attracted due to gravity, and in some special cases the gravity just is enough to make it glow. It starts a fusion reaction in the core, and that's how a star is born. Now, depending upon the initial mass of the protostar, the star can undergo three different types of stellar evolution. Let's see the first kind of evolution a star can undergo. When the mass of the initial protostar is less than 0.08 times the mass of the Sun, the object does just fail to become a star. In that case, there isn't sufficient temperature in the core to sustain the hydrogen fusion reaction, and thus these objects are termed as failed stars. In astronomical terms, we use a special word called brown dwarfs for these kind of stars. How the stellar evolution will occur if the mass of the star or the initial protostar is less than 8 times the mass of the Sun. In this case, we have a main sequence star with mass about 6 times the mass of the Sun. As you all know, what's happening inside the core? The hydrogen is undergoing fusion reaction and is getting converted into helium, and that is what is the source of a star. Now, after a few million years, the hydrogen gas will all get exhausted, and what essentially remains is only helium. In that case, the star's outer peripheries start expanding into the outer space or the outer interstellar space. The star wants to grab more mass by acquiring more hydrogen from the surroundings, but in that case, the radius of the star becomes 100 times more than its initial radius. This is what will happen with a star like the Sun. The Sun, in its next evolutionary stage, will become a red giant. For a star like the Sun, after the helium has fused into carbon, the core of the star collapses again. As the core collapses, the outer layer of the star is expelled, and a planetary nebula is formed by the outer layers. The core remains as a white dwarf and eventually goes to become a black dwarf. Now have a look at the second type of stellar evolution a star can undergo. When the mass of the initial protostar is more than 8 times the mass of the Sun, this kind of stellar evolution is what is predicted. So here is our star. This star, like a star like Rigel or any other star with mass more than 8 times the mass of the Sun, the star will undergo the same kind of stellar evolution till the red giant phase. A massive star will undergo a supernova explosion after the red giant phase. If the remnant of the explosion is 1.4 to about 3 times as massive as our Sun, it will become a neutron star. These neutron stars with very high magnetic field intensities ranging about billions of Teslas are termed as PULSARs. The core of a massive star that has more than roughly 3 times the mass of our Sun after the explosion will do something quite different. The force of gravity overcomes the nuclear forces, which keeps proton and neutron from combining. The core is thus swallowed by its own gravity. It has now become what we know as a black hole. That's all about stellar evolution. Some more interesting stuff coming in the next video. So don't forget to subscribe.